Thank you. Hi. So it's the first session after lunch, so it might be hard to listen because lunch was good. So let me introduce myself. My name is Roman. I work for HARMAN Connected Services as a product manager, and my role is in automotive, basically the automotive HMI development for instrument cluster and digital cockpit. So in my presentation, I would like to tell you how we in HARMAN and within my team, we see the trends in automotive HMI development, and basically what are they and how Qt helps us to deliver the products and the software to our customers. So I would like to start with a short introduction about HARMAN, because maybe most of you know HARMAN as a producer of the audio equipment like HARMAN Kardon, JBL, and AKG. But we have other divisions as well, which are targeted for automotive, and we deliver quite a lot of market-proven infotainment solutions to our customers, which are major OEMs here in Europe and over the world. And myself, I'm from the Connected Services division, which is mainly responsible for the software development. And we have certain strategic partnerships with the major OEMs in Europe for software engineering. And since a few years, we are a service and automotive partner of the Qt company. So that was the introduction, and basically my statement is that HMI is very important nowadays. And I would like to elaborate a bit more on that because, we have started a lot with the mobile generations, with the iPhones and Android phones, and we have quite high expectations on how and what we can do with them. Basically, they are having a lot of connected experience. They provide us personalization possibilities, software updates, and so on. And our expectations are quite high. We would like to get the same experience in the cars. And basically, we get frustrated if we don't get that. And for a few years back, I think that was quite a gap in the mobile and the embedded devices, which the industry is going to minimize right now. Yesterday's extras and features like heated seats or ventilated seats or airbags are now more like commodities for everyone. And I would say that partly the competition has been moved to the software space. Because right now we want software features, we want to have ADAS, we want to have projection mode, we want to connect our smartphone and get CarPlay or Android Auto there. So that we are competing in that area really hard, and therefore this is the point for differentiation between one vehicle to another vehicle, one brand to another brand. And this competition takes place, but it's very different from the mobile phone competition, because for the mobile phones, you having very similar UI for all of the Android phones, and you have some maybe minor changes, but basically it's all the same. With the automotive world, that doesn't work, because for automotive, the UI UX design is a state of the art. For each vehicle, for each brand, you would like to be recognizable. You don't want to mix one vehicle brand with the other vehicle brand, so that one size doesn't fit. And it is really a design task, design masterpiece to go through and to develop the UI UX and HMI for each specific brand. So how to cover all these market requirements? That was the question that we started with a few years ago, when we have decided that we build up our own product based on the Qt framework. And with this product, we augment Qt framework with the necessary automotive specific scenarios and implementations. We call that the framework part, which is the core part, which provides the functionality for the multi-screening and seamless user interaction between multiple displays and so on. And the standalone tools and plugins part, which we call the tool part. So that all is kind of a complete solution based on Qt framework for automotive, which we are using to serve the customers with their with this market needs, with these market trends. And we have chosen Qt as a base technology, and I'm very confident that the initial choice of the technology is really defining a lot throughout the product life. And there was a huge list of the pros and cons, what should be the technology that we should be based on. And this pros list is here on the screen, and since a few years, it is really growing to some extent, and we are quite happy that this is the technology in the basement of our product. To name a few, we are happy to use Qt on every automotive domain, in the instrument cluster, in the infotainment part, and by that we enable more specific use cases and scenarios of communication between the domains, collaboration. So this is one aspect. The second aspect is that we like the direction the Qt moves with the design and developer collaboration, because this is, I would say, the really important problem to overcome, because sometimes we see that designers and developers might be a bit disconnected. And as an engineering manager, I see that this is really a problem for some of the projects that we have. So this strategic direction is quite good, and we are supporting that much. And of course, the baseline which Qt provides is stable and functionally rich, so that we are quite happy to use that and update to the latest as soon as it's available. I would like to bring a few examples of the UI that we developed at HARMAN for different shows. This one shows the Rinspeed concept car, where the user interface and the user experience interior completely has been designed by HARMAN. And it's interesting that it provides, it connects up to 16 different displays and touch panels and projectors. So within this concept car of the future, autonomously driving cabin, we have both personal and shared experiences, and we have this multi-screen environment working all together seamlessly, and the information flows are going throughout all the displays. Within this, another example, which we prepared for CES last year, this is the entry digital cockpit, meaning that it is a single huge display in the front, which combines both the instrument cluster information and the infotainment information, where it is blended on the single display in many different combinations, depending on where the user wants to get it. The another example is reference Cockpit HMI for HARMAN platform, mid and entry segment, where we have support for up to 4 displays, or maybe 3 displays and the HUD, which work also in combination with one another, and we are able to change the colors and the screen and so on. So by that, I would like to go a bit back into the history and explain what was on these 3 examples and why they see this as a market trend. So basically, starting with the dashboard, we go back to 1948, where the first ever car radio appeared in the car, so that the user got possibility to listen to some radio station. And then, so that was like a multimedia gadget, multimedia device in the car. And then it developed a bit more into a stereo device, and then another carriers were enabled, like cassettes, tapes, then CD players, CD changers. But the main point where it's changed a lot was in 1998, where the navigation has been added, because navigation is seriously a different function. It's not the multimedia anymore, it's the infotainment unit since then. Because from that point, software started to play seriously big role within this infotainment device. And then we see that also since then, the feature scope of the infotainment device expands even more. It is not right now also the climate control, the car control, the settings, the ADAS. Everything seems to be connected to the head unit and operated through the head unit. So it's not anymore a multimedia device. It's the main center of the settings in the car. And right now, by fact, we have this scope that we have central IVI, two-dimensional cluster, virtual instrument cluster, or physical instrument cluster, optional heads-up display, optional rear seat infotainment. So this is our current time. And in the future, we might have more into a 3D cluster, augmented reality cases with the HUD, more of the displays, because the number of displays explode. We have more and more of displays and touch panels in the car. So we would need to know and learn how to operate with them, how to have seamless user experience, so that I don't see the boundaries between these different displays. Sorry, I think something is maybe. Yeah. So regarding display possibilities, we see that the technology is also evolving, and we have much more possible right now with the display. So we can do the bonding of the display into something. We can do a free-form displays like rounded. We can have curved displays. We can have curved displays where we incorporate some rotaries inside, like rotaries, knobs, touch panels. So that means that we have much wider possibilities to enable more design of the car interior by this. Then regarding digital cluster, we had electromechanical stuff long ago. Hybrid is maybe the current state, where we have both the quartz or electromechanical gauges and the LCD displays with gauges in the virtual mode. And then also we are moving into two-dimensional standalone clusters connected to the head unit, which is also what we have right now. But in the future, we expect that these systems get more integrated. We will get more of the 3D stuff inside the instrument cluster, and we get them more connected. So this is the example of the holistic digital cockpit, and by the holistic, I mean that all the systems work interconnected. This is also the show car that HARMAN did for CES, and the good thing here is that this interior, we do not implement the head unit inside the interior. We are basically implementing the interior by the means of the infotainment system, because everything what you see here are mostly the displays. We have the panoramic display on the front, and the central we have the curved display with the multi-touch panel also in the front and the center. Then we have electronic display for the e-mirrors, and we have the virtual cluster display. So everything what we see inside the car is mostly implemented in the HMI. Therefore, this is quite important topic. From the system architecture perspective, we also see some kind of evolution here, that the system gets centralized to some single SoC or some central unit, which is formed by a set of SoCs where everything resides. And basically, thanks to hypervisor technologies and to evolvement of that, and thanks to SoCs, which became capable to host many different operating systems at the same time. The good thing here is that we can execute Qt in most of the domains, and we can leverage on that with the we can leverage on the Qt in all domains and get the additional features of inter-domain communication implemented by Qt by that. And then the cockpit evolution further would go into the connecting the car to the cloud. For example, to the sorry, but it looks like it's changing the slides by itself. Sorry, maybe that would fix it. So I see that the car should be connected to the cloud. Do you know how to fix that? I mean, I see that the slides are changing by themselves automatically. I don't know how to change. Maybe that's okay. Let's see.
That's our way of keeping the speakers on time.
Okay, sorry. Yeah, so we can offload the heavy computing algorithms to the data center in the cloud. For example, if we want to enable certain personalization or algorithms that would predict something for you, for example, based on artificial intelligence or machine learning, then you can offload them to the cloud, and you can have a thin client installed in your head unit to get the information and to visualize it in the HMI level. And then from the UI perspective, I would say those are the main aspects of how the UI is globally evolving. And I would go rather quickly through each of them and explain how Qt helps here. So starting from the functional and branded UI, I would say that each vehicle or brand requires state-of-the-art UI UX design to be developed. And maybe that would be quite obvious, but we are using a model view controller approach for that, because that helps us to separate the C++ coding for the HMI business logic from the UI coding. And then Qt provides us C++ to KML coupling, and that from the user perspective and from customer perspective allows me to have significantly different look and feel and significant customization possibilities between different brands and vehicles on the same functional baseline. And as I also want to have diversity of the vehicle configurations and the HMI applications, then we also need to have a code separation into some functional modules that Qt helps to do. And then by that, we can create a standalone applications by using Qt Creator plugin architecture with the open code to be able to develop our own custom plugins to, for example, generate a lot of code by certain templates, or help to generate the HMI data model for application to work. So that's really helps to accelerate the development, and thanks to open code of the Qt Creator API. The next is seamless user experience and multi-screen synchronized UI. So for this one, I would say that the main trend is that the vehicle cluster and IVI displays, they have boundaries which right now get blurred. That means maybe you notice that the central information display goes smoothly to the instrument cluster slowly one by one. So right now we have like a panoramic displays which still have some boundaries between, but the next step obviously is to remove those boundaries, because as a user I don't want to get them. I don't care where I'm running on real time in this display and Linux or Android another display. What I need is to have information delivered to me where I want it. And for example, if I want a graphical information to be delivered to the instrument cluster, then that's a heavy task on the Qt Valent server to basically do the screen composition in the way I need it. Between own applications, between third-party applications, and between the mirroring content like projection modes, so that I get my surfaces, my visual information where I need it. In this example, there is the camera information delivered to the instrument cluster from e-mirrors and rear view camera. And yeah. And by the seamless user experience, I mainly mean that I would like to enable native or natural gestures for myself to kind of use them. For example, I can use swiping from one display to another, like dragging and dropping of the certain elements from one screen to another. And for that, if I use Qt in both domains, then I leverage on the Qt IPC mechanism, like Qt remote objects, that provide you a lot. If I don't use Qt in both domains, for example, I have a surface which is shared by somebody else, then I can use the screen composition. And we have a very good example last year when we developed a Qt 3D Studio presentation, which helps us to align the streaming surface casting from another domain into a Qt4D Studio presentation and aligning that in the form of animations and so on the timeline. From the UI perspective, we want it to be context adaptive and self-learning, and there are two main definitions here. One is the driver, and another one is the context. So as soon as the driver is identified, then the car needs to identify the context. For example, am I on the city drive, or am I on the highway drive, or a sport mode? And then I expect the HMI to deliver the available information for me where I need. For example, if I'm in city drive, I would expect to have a navigation map on the full screen in the cluster and the vehicle speed somewhere maybe on the second stage. But then if I'm on the highway drive, then I don't need the navigation information on the full screen. I need to know that my next exit, like in 20 kilometers, but I need to know which ADAS features are enabled right now, which driving mode am I in, and so on. So this adaptation to a context and a driver is really a next step for the UI development with the connected experience to the cloud as well. And the last is the high-quality graphics and 3D. So I think, my personal opinion is that the clusters, instrument clusters, are right now quite popular because of rich functional features that they provide. I can configure what I want to see in each part of the screen. But from the graphical perspective, I think we still have a room for improvement and to go with the even higher requirements on the fidelity of the graphics, to go into the 3D modes, to have a more smoother animations and more complex scenes. And I think that this is really the future of the instrument cluster, to be developed as a fully 3D clusters with a strict performance KPIs. And for that, a 3D Studio toolchain and runtime provides quite a lot in the key steps of the HMI development, and also compared to the competitors, significantly better control over needed optimization on the targets. So basically that concludes my overview of what, from my point of view, was happening and is happening in the HMI area, in the UI area. So thank you for listening.